Yes, you're welcome to Seremba Online School. My name is Katerega Fred. We are going to continue with our electricity senior force, then an experiment to verify Ohm's law. In our previous lesson, we stated the Ohm's law, and you all understood how the law states. Now we are going to describe an experiment to verify Ohm's law. This is the circuit diagram. It is very important because when you state down the procedures basing on the circuit diagram, it will become easier for you. So the description, like as you see, A ammeter, V, this is voltmeter, S is the rheostat, K is the switch, and this is our cell. You are seeing it. That's why we're having our battery. Then it's very simple. Now I'm going to base on this circuit diagram, and I give you the procedures. Like you see, the cell, we're having our cell ammeter, then what else? Rheostat, cell ammeter A, rheostat. Our rheostat is S, switch K, then what else? All these ones, the rheostat, the switch K, the cell, and the ammeter are connected in series. We shall see further what to connect in series is, but what I can give you briefly here, if something is connected in series, current does not split. Like you see here, current is coming from here, it goes passing through here, so current does not split. That's all about connection in series, but we are going to see in our next lesson when we talk about the connection of resistors in series. Then after describing that, let us talk about what else here. This resistor R, voltmeter, we're having cell ammeter A, rheostat S, switch K. What are you forgetting? Also, you can add and the resistor R are connected in series. Then the voltmeter, we can say the voltmeter V, this is our voltmeter V, is connected in parallel. The voltmeter V is connected in parallel across the standard resistor. You know, when I talk about the standard resistor, that means its resistance must be known. Across the standard resistor R, like you see, then that's step 2. Voltmeter is connected in the parallel across the standard resistor R. Now we are going to close our switch. You know, when you close the switch, current starts flowing. And since this is an experiment, you must record the values, because ammeter measures current and the voltmeter measures voltage. It will help you determine the potential difference across this resistor. So you can write down and you say that the switch K, or we can say switch K is closed. Switch K is closed. Are we together? Switch K is closed, and the ammeter reading I, the ammeter reading, we are going to call it I, and the voltmeter reading V are noted. Or you record them. Are we together? Remember, this is an experiment. The moment you close the switch K, current starts flowing immediately. It flows from the positive side of this cell. It continues the ammeter will give you the reading of that current. Then as well as also the voltmeter will give you the corresponding what reading. That's why I've said that switch K is closed and the ammeter reading I and the voltmeter reading V are noted or are recorded. Are we together? Okay. Then we can continue and say, now the purpose of this rheostat, remember this is an experiment. You don't need only one reading of I or one reading of what V, but we need several what readings. So therefore we must use this rheostat. We adjust it to set the current such that we can determine the corresponding values of what V. Also like that procedure, that the rheostat, our rheostat, we have called it S. You can say that the rheostat S is then adjusted to in fact it has is then adjusted for different, let us say, for different values of I and V, because you have already told us that I is the ammeter reading and V is the voltmeter reading. That means that when you adjust the rheostat, you set the current. The moment you set the current, you also again determine the corresponding voltmeter reading. I can give you an example. Like for example, you can set when the current is 2, then the voltmeter reading comes when it is 1.3. You said when the current is 3, the voltmeter reading becomes when it is 1.0. So like that, yeah? So for the different current reading, it will give you the corresponding voltmeter what reading. So the rheostat S is then adjusted for different values of I and V. Okay? Or you just adjust the rheostat to set the value of current and determine the corresponding voltmeter reading. So then when you reach there, remember now you are having several values of I and V you have recorded. Okay? And in any experiment, you must talk about the table of results. You tabulate your results. Then you say the results are tabulated in a suitable table. The results are tabulated in a suitable table. Remember, you are going to tabulate this table. It has to be columnar. You just show just something very small. You include values of I, current reading, and that current is in amperes, and the values of V, that is the voltage, in volts. That's just the simple table to show the results are tabulated in a suitable table. After talking about that, then you have to talk about the graph. Then you can say a graph of V against, others can call it a graph of I against V. I'm going to say a graph of V against I is plotted. A graph of V against I is what? Plotted. Remember, you are having values of current and values of what? Voltage. Now you must plot a graph. So this graph, when you plot it, you're going to obtain a straight line graph. Are we together? So it's plotted. This is how it will look like. I can put here, this is the voltage in volts. Then this is the current in amperes, and the graph, I'm going to obtain a straight line graph. I see it like that. That's a straight line graph. Then we are coming to the conclusion. Now remember, these are our values for voltage on the vertical axis and for current on the horizontal axis. Then that's the procedure. Where is now the conclusion? Now we are coming to the conclusion. Because this is now the diagram of the experiment, the setup. These are the procedures. Now we are coming to the conclusion, okay? Remember, you must make observations. You have observed, you have recorded the values, then we are coming to the conclusion part. So what does this straight line graph imply? Are you together? So you say a straight line graph, is obtained. So the graph you have plotted is a straight line. A straight line graph is obtained, which shows, what does this one show? That when the value of current increases, the voltage also increases. When you increase current, voltage also does what? Increases like that. What does that one imply? That the two are directly proportional. When current goes on increasing, also voltage will increase. So a straight line graph is obtained, which shows that current is directly proportional to the voltage. Shows that this voltage is directly proportional to the current. Remember, in the statement of Ohm's law, we say that the current passing through a conductor is directly proportional to the potential difference across its ends, provided the temperature and other physical conditions remain what? Constant. Therefore, what we are looking at are these two directly proportional. This graph indicates that they are directly proportional. It's having a positive slope. Therefore, now our conclusion statement should be this one: the straight line graph is obtained, which shows that current is directly proportional to the voltage. Hence, Ohm's law verified. Now that can be a simple verification of George Simon Ohm's law. It is very simple. In summary, draw the circuit diagram. Use this switch, ammeter, resistor, standard resistor, voltmeter, rheostat. Talk about the connections like we have seen, tabulation of the results, draw the graph, and come to the conclusion. So we are going to stop there for today. We shall continue with more of that in our next lesson. Thank you.